Hi, I'm Sham Sai. I'm an artificial intelligence major here at Carnegie Mellon University, and my project is robotic fault detection using temporal GANs. So, fault detection is a need in every single robot. And that's because we're sending robots to places like the Atacama Desert or Mars, where humans can't readily access these places. And what that means is that robots have to do fault detection on their own. They have to be able to detect when they're in a fault state rather than in normal running conditions and be able to do something with that information. Typically, this was done through expert systems. Someone that knew the robot well looked at conditions where the robot could fail and tell the robot what to do in those specific conditions. Now, that's great, but deep learning methods have started to take off. So, recurrent neural networks, GANs, k-means clustering, Gaussian mixture models are all different ways that have been applied to do fault detection in robots. You'll notice that a lot of these methods are generative. That's because it's really hard to collect data on a robot, and especially faulty data. And that's because robots typically are in normal running modes, right? They're almost never in faulty modes, which is why there's so little faulty data and why it's so hard to collect faulty data, which is why these generative methods might work better than a supervised method. And it's in one of these papers, right down here, that I got the inspiration for my project, right? In the future work section of this paper, it said, perhaps a temporal GAN architecture might work better for fault detection because temporal GAN architectures will be better for time series data, and robots are outputting time series data, right? Their state at a certain time. So I went out to research this option, right? Can we use a temporal GAN architecture to do fault detection? The architecture that I settled on is a recent one. It's called TimeGAN. It has 4 different components. First, on the left half is an auto-encoding component. We have an embedding function and a recovery function, right? So essentially, we're going to a latent space and we're going back out to the normal vector space. And we're using this latent space to really simplify things down. Then, in addition, we have the normal GAN component. We have a generating function and a discriminating function, and these two function on the latent space. What makes this architecture different than normal GAN architectures, though, is that all 4 components are implemented using a recurrent neural network. What that means is that because recurrent neural networks train on sequences, right, they're better on time series data, which means that the hope is that this architecture is better for fault detection for robots because that data is time series data. So how are we going to test this? First things first, we need to have robot data to test on. And to do that, we use the Gazebo simulator and the Turtlebot model, right? And you'll see that on the next slide. In addition, TensorFlow was used to implement TimeGAN, and in order to run the model, we use Google Cloud Platform because my laptop is not going to run this model anytime soon. So here's a look at the simulator that we used. The Turtlebot model in Gazebo comes with this nice navigation software, so I'm able to click anywhere and the Turtlebot model will go there. We collected data of both the normal data and faulty data, right? So for the normal data, we just had it run and collect the odometry data. For the faulty data, what we did is we broke a wheel, or we had the robot crash into an obstacle, right, and collected the odometry data from that. And using these 2 data sets, we wanted to train the GAN, TimeGAN, and then also test to see if it could differentiate normal data from faulty data. And here are the results. So the first thing is that we want the generator in the GAN to be able to model the same distribution as the original data, right? And as you can see here, it accomplishes that, right, to a certain degree. This TS&E plot is 2D embedding of the data, right? And we can see that the synthetic data and the original data, the generated data and the original data we passed in, have a similar distribution. And you can see those on the metrics to the right as well, though there is some room for improvement. What's exciting, though, is the discriminator, right? So we wanted the discriminator to be able to tell the difference between normal data and faulty data. And we can see this in the statistics that we've collected. With the normal data, the discriminator had a discriminative score. And what the discriminative score tells us is how well is the discriminator able to distinguish this data from the normal data, right? With the normal data passed in, right, it's very hard to distinguish. That's because the generator has done a good job. But when we pass in faulty data, it's very easy for the discriminator to distinguish that data from the normal data, right? The loss is quite high. And that's good, right? That shows us that TimeGAN has potential for robot fault detection because, one, the generator is able to model the non-faulty data, and two, because the discriminator is able to differentiate between the faulty data and the non-faulty data, which is exactly what we want, right? We wanted the discriminator to tell us, hey, this data is not from the original distribution, so it's likely faulty. Because of time limitations on the semester, it was a short semester, I wasn't able to tune parameters in the TimeGAN, run the TimeGAN for as many iterations as I wanted, or even run a more complex data than just the odometry. This is all future steps that I can take. And in the end, I just want to thank Dr. David Weddergreen, my advisor for this project. He stuck with me through highs and lows this whole semester, and I've learned a lot in a short amount of time this semester, and I owe a lot of it to him. I'm very grateful to him for the opportunity for this independent study. And I'm also grateful for the School of Computer Science giving us undergrads the opportunity to learn something we typically don't in a classroom setting. And I'm thankful to both of them, and I'm very happy with how this independent study has gone. You can reach out to me at shamsai.com if you have any questions, and that's all for now. Thank you so much.